Okay, so as in the last video, we discussed about evaporation, right? Initially, we discussed about evaporation, what it is. Evaporation takes place in the open container. Since molecule is kept from the open container, it has a leniency to get the molecules of the water uh, is kept from the container, right? But when we talk a closed container, there we saw molecules cannot be kept from the container, so they create a pressure just above the liquid surface, and this is what we call the evaporation, right? So I must mention here what we discussed yesterday. We discussed evaporation. Then I told you this too, that vapor pressure is always made using the what closed container. It is never ever made using the open container. Always made closed container, because we have discussed about uh, open and closed container as well, right? Why it is made in the closed container? Since molecules of the water cannot be kept from it, right? That's why they create a pressure just above the liquid surface, and this is what we call the vapor pressure. So vapor pressure is made in the closed container, not in the open container at all. So in today's video we are going to discuss that what are the factors that affect the vapor pressure. So today we are going to discuss factors affecting vapor pressure. Factors affecting vapor pressure. We're gonna discuss two main factors, all right, and that will gonna lead us to the Raoult's law. Okay, okay. So the what the says first factor says that vapor pressure. Let me write here first, then I'm gonna explain you. Vapor pressure has nothing to do with the shape and size of the container. Okay, but it must be a closed container, right? Because we have already discussed that vapor pressures are made in the closed containers only, right? Closed container. Again, let's read this factor so that we must understand what the first factor says. Vapor pressure has nothing to do with the shape and size of the container, but it must be closed container. Now see, whatever the size of the container is, if you have this container, it's okay. You have nothing to do with the size of container. You have nothing to do with the size of container, right? If you have this container, it's okay. You have nothing to do with the size of container, right? You have nothing to do with the size of container. You just need size, or you can say shape of the container, right? Now see, the size of this container is small and the size of this container is large, right? You can see the shape as well. The shape of both containers are distinct. They are not similar or same at all. The size and shape can be different, but the containers must be closed container. Now see, this is closed container, this is closed container as well. So vapor pressure has nothing to do with the size and shape of the container. However, the containers must be closed since vapor pressure are just made in the closed container. They are not made in the open container. Alright, so let's discuss the second factor. What does second factor says? It says vapor pressure um, is affected by the nature of the substance. Is affected by the nature of the substance. It has nothing to do with the size and shape of the container. However, containers must be closed. The second factor says vapor pressure is affected by the nature of the substance, which means vapor pressure does not depend on the size and the shape of the container. However, it depends on the nature of substance or the nature of liquid present in the container, right? Now see, we have two types of liquid. We have two natures of liquid. The first nature is volatile. Volatile substance. And the second is non volatile. Now I'll tell you what volatile is, what non volatile is, each and everything, right? But vapor pressure depends upon the nature of liquid. It has nothing to do with the size and shape of the container. However, it depends on the nature of liquid or nature of substance present in it, right? So we have two natures